not a 0.
Right. The number before the decimal cannot be 0. Dimitri?
It can't be like 2 numbers.
Can't be 2 digits.
No, he stole.
Stole yours. Eva?
The base of the exponent has to be a 10.
The base has to be a 10. And then our exponents are integers, right? Positive and negative whole numbers. So we went through that yesterday. Then we pretended like it was Friday, and we took notes on converting. So we spent time yesterday converting from scientific to standard, where we looked at the exponent that told us how many loops to move the decimal, put in our placeholder, and then we had our values. Remember, positive exponents we move to the right, negative exponents we move to the left. Okay, so it's still, we're just going to continue with our Friday notes. So you don't have to put a new date. This is still Friday, right? So we're going to do standard form. To scientific notation. And this is going to be for large values. It's on the video.
Oh, no, delete that. Delete that.
You can't delete part of the video.
No, you're a famous YouTuber.
No. I know how to record one thing at one time, and that's it.
Wait, are we still on there now?
Yes.
I know how to
Whole
edit
conversation?
The whole conversation's on
Can I
there.
say hi? Wait, can I shut up on YouTube?
No.
Okay. So we have this very large value number, 1,165,000,000, and we want a shortcut. So we have some steps.
Can I just put it in a box? Because I can't do those 5s.
That's fine.
That's what I did. Squiggly box.
So you're going to place the decimal after the first digit because we're putting it into scientific notation. So you can only have one digit in front of the decimal. Step 2. Create loops to move the decimal to the end. And then you count them, and you find out that there are 9 loops to move this decimal to the end of this very large value. Step 3 is to write the value in scientific notation. Anybody feeling super confident and want to tell me what you think it would be? Lainey?
Oh, no, it's not if I can use the restroom.
Not right now.
I know.
Riley?
1.65 times 10 to the 9th power.
Perfect. 1.165 times 10 to the 9th power. How did Riley know that it was going to be to the 9th power?
Because there's 9 loops.
The 9 loops. That's what tells us our exponent is going to be. Xander? Okay. Well, I might have to give you the notes after so you can copy them. And that's fine if you want to just type. Here, here's what I'm going to do. Hold on.
Wait, do you have the notes you already started writing?
Huh?
Do you have the notes you already started writing?
Yeah. I write them in third period, and then I make sure I use them the rest of the day so you all have the same notes. Did we talk about this?
Nope.
Feels like a very familiar conversation.
Ooh.
Maybe it was a different class.
Are those people's birthdays for today?
Yep.
Did you know I
Joshua?
can't be up there?
Because the base is always 10
Oh.
for scientific notation.
I'm not
Keaton,
cool enough to be on the birthday.
when's your birthday?
October 15th during break.
I'll still put it up there at some point.
My birthday is
You'll still get a pencil.
My birthday's tomorrow.
Wow.
Oh, it's Arden's birthday?
Jimmy, that's a lie.
Okay, so let's do the same strategy here with the number 52,000. Where's my decimal going to go? Nia?
Well, never mind. I thought I knew better.
I know.
Dimitri?
Is it 5 point? Is it final?
Yep. Right after the 5. Then I'm going to make my loops. I know that there's 4 of them. So what will be my answer in scientific notation? Keaton?
It'll be 5.2, and then it'll be times 10 to the 4th power.
Yep.
That's
I know told this yesterday, but why does it have to be like to the 10?
Because
Thanks.
moving the decimal is like multiplying something by 10 over and over again. So that's 10 to the 4th power. Mhm. Yep. All right, last example for this page. $657,101,000.
wow.
How do you like reading these big numbers?
I just make them up.
I got that. Well, the answer's gonna be 7.
Where is my decimal going to go, Spencer?
After the 6.
After the 6. It's going to move 8 loops. What is my scientific notation going to be for this value? Dimitri?
I don't know, but it's 6.5.
6.57101, because you have to show all the digits until then you can drop all the zeros. That's the shortcut, right?
Show the digits until the 0.
Until you get to the repeating zeros. Yep. Nia, do you know the answer?
Oh, I think I do.
Okay.
6.5 times 10 to the 8th power.
You're close. It's 6. You have to show all these digits. So 6.57101 times 10 to the 8th power. Because really what you want to be able to do is recreate the standard form using the scientific notation. So if I was to just have this, then I could go back to yesterday's when we started these notes, and I should be able to recreate this number in standard form. Right? In theory, you should never miss a scientific notation problem. Because if you did it right, you should be able to recreate the number you started with.
What
Yeah?
if you just like, on the start, can't you just like write the numbers out and then see how many numbers are after the 1?
That's not really I mean, yes, you could, but I think it's going to take you a little longer. It's up to you. Yeah, I mean, there are shortcuts, yep. Okay, so that's for large values. Now let's move on to tiny values. Another page, last one.
should record us playing Silent Ball. We're done with games.
There'll be silence.
Nope, we have other things to do today. No silent ball.
Wait, we can't do
We
silent.
watched I don't know.
We have other things to do. I'm sorry.
I hate Harry Potter.
Mrs. Engler would not be proud.
I hate it. I've always been scared of it.
You've been scared of it.
I've been scared of Harry Potter.
I was scared of the wisp from Merida.
Chris is actually scared.
I know.
Okay, so we have this teeny tiny value. I know it's small because there's a decimal and then there's all these zeros. So that tells me it's worth very little. There's 5 zeros after the decimal, if that's what you guys are.
Thanks for clarifying.
Yep. So of course I have steps again. So the first step is to place the decimal after the first non-zero digit.
Mrs. Mom?
Yes.
What is like your favorite thing to teach in math?
I don't know. I get pretty nerdy about all of it, so I don't know if I have a favorite. I do. Okay, I lied. I like teaching. It's called linear regression.
Is that
Oh, I know what that is.
Well, we're gonna do it in 8th grade, like in pre-algebra a little bit too. But in algebra, I like it because you can you can do it yourself, and then you can compare it on the calculator and see like how close you got on your own, and that's like super nerdy exciting for me.
The only thing I'm good at in math is like calculating tax.
Okay.
That's easy.
I'm good at the addition.
Okay.
No, it's my teacher's fault, but I didn't learn like long division till 6th grade.
I still
Well, I'm glad you know it.
Like it took forever. In 5th grade,
I
we learned an area and all you don't know the time.
I don't know
can't remember
long
it now.
division.
Same with borrowing.
Calculators.
Yeah, I forgot how to
Yeah.
borrow.
I don't know how to divide.
Yeah.
I didn't. Okay. I love
Okay, so this is similar. We'll look for it after. I'll put the lights on. Okay, so this is similar to the large values. We're going to create loops to move the decimal to the front. So we're going to be moving the decimal to the left. Or count how many it would take to get there. 1, 2, 3, 4, 5, 6. So it would take 6 loops to move it back to where it was.
That's step 3 or okay.
Oh, should say step 3. Thank you. So step 3 is write the value in scientific notation.
Did your hand hurt after running?
Nope. I'm used to it.
And my hand always hurts.
My hand always cramps up.
I like pushing.
But this is like what I do all day, so my hands are like, it's fine.
Basically like no.
You could just like type it.
But then like, I don't think that is gonna work. I don't think that's the best way to give you guys the
It'll
information.
take forever.
Okay, so who wants to tell me, what do you think this will be in scientific notation?
Oh,
Keaton?
so that, wait, this one?
Yep, the one we just did.
Wait, so when I do the 0, 0, 0, 0, 0, oh no, 6.8
6.28 times.
10 base and then to the power of 4. 6.
Negative 4. Or negative 6.
Negative 6. Why, Chris?
Because you're moving to the left.
Because I'm moving to the left.
Yeah, Chris.
Nice.
4 in it.
Negative 4.
Nice. So what this tells me, Lainey, what this tells me is that if I wanted to recreate this number in standard form, I would move this decimal 6 places to the left, and I'd end up where I started. Right? So that's one way to think of it. All right, example 2.
I'm not gonna fall.
Please don't.
I will not.
Not again,
I promise.
You wouldn't on purpose, but please let's just sit our seats down. Thank you.
How many times have you fallen?
I've fallen like 5 times.
Okay, so where's my decimal going to go? Before or after the 5? After the 5. And then I'm going to count my loops. Nia, are you writing any of this down?
Yeah.
And then what will my answer be in scientific notation? What do you think? Danny?
Oh, it's 5.06 times 10 to the negative 4. I knew there would be a
So if they're really small numbers, they always be like into the negative.
No.
Right, so if your standard form has the decimal in it like this, that's going to be a negative because you'd have to go backwards to get it there.
I remember I was talking to Officer 7, and I accidentally said babysitted, and I was so embarrassed.
Babysitted.
It's not a word.
Did it?
Babysit.
Okay.
Done with it.
Also,
You know what? You bully me every day.
Remember that episode
I
of,
have to think about it. You.
dude, I've been on there.
If you're okay with that.
It was in like 4th grade.
What did you do?
I'll tell you it later after the video's done.
How many zeros?
7.
7 zeros.
Sammy.
Joshua?
Is like the fourth number to the, is that a 2 or 7?
It's 7012 at the end. 7012.
Are there 7 zeros in that?
Yep.
Wow.
Okay, so that's it for our notes.